Okay, first things first, before we go into this, quick reminder, whenever we use the word and in probability, it means we need to multiply, and whenever we use the word or, it means that we need to add. Okay, so put a plus sign there for adding. Alright, in this video we're going to talk about tree diagrams, and in this particular problem we're going to look at two guys, Bob and Bill. And we're going to have a hypothetical problem where Bob and Bill are trying to catch the bus to go wherever they're going. Now, tree diagrams work best with independent events, and independent events mean that one event doesn't depend on the other. So, what we already know about Bob and Bill? Well, so this is going to be Bob here, and we're going to check the probability of Bob being able to catch the bus, so to go wherever they're going. So, the chances that Bob catches the bus in the morning is 0.9. So this is provided that he catches the bus. So I'll just put a C there for catching the bus, which means that the probability of him not catching the bus will be 0.1, because probability is between 0 and 1, the maximum it can go to is 1. So all we need to do to find out him not catching the bus is just 1 take away 0.9. So that's how I got that there. So I will put an N here to say that he does not catch the bus. Bill, on the other hand, more of a lazy dude. So he's gonna catch the bus now. So we're going to say that the probability that Bill catches the bus is 0.7. Obviously, for him not catching the bus would be 0.3. So just the same way, I'm going to put a C here for Bill catching the bus and an N for Bill not catching the bus. Now, because Bob can either catch it or not catch it, I will need also this happening here for Bill. Again, it doesn't matter who you put first, the answers will be the same. So Bill catching the bus, 0.7, and not catching the bus, 0.3. So C for catching the bus and N for not catching the bus. Okay, so there's my tree diagram for Bob and Bill. If I wanted to add, let's say, a third person, I could easily just put that down here, put a third person there, and then I will have to go through the process of them catching the bus, not catching the bus, catching the bus, not catching the bus, catch, not catch, catch, and not catch. So you can see that your tree diagram can get quite complicated quite quickly, but it's very useful. It's a very useful tool. Okay, now that we've got the tree diagram done, let's use it to solve some problems. So I'm going to stay on the same page. Let's just say the first problem that I want to solve is the probability that they both catch the bus. Both catch bus. So if I want to know the probability that they both catch the bus, well, simple business here. I'm going to use my blue to express how we use the tree diagram. So Bob catch the bus and Bill catch the bus. So that's probability of they both catch the bus. So Bob catching the bus is 0.9, and I use the word and, so I have to multiply. The probability that Bill catches the bus is 0.7. So 0.63 is my answer, which is just over an even chance that they both catch the bus. Okay, now let's look at a different problem. Let's just say Bob catches the bus but not Bill. So probability that the event is Bob catches the bus but not Bill. Okay, Bob catches the bus, but Bill doesn't. All right, well, let's see how many possibilities we've got here. So for this one, let's see, I'm going to use green. So Bob catches the bus, Bill does not catch the bus. And so that's how I'm going to follow my tree diagram to get my answer. So I can easily now pop that in. The probability of Bob catching the bus is 0.9. And the probability of Bill not catching the bus is 0.3, which gives us 0.27. It's a small probability, and it makes sense that it's a small probability because of the fact that, well, both of them have pretty high probability, high likelihood that they will catch the bus. Okay, all right, let's have another look at another problem. Let's just say at least one of them catches the bus. Okay, so at least one of them catches the bus. So I'm going to say, I'm going to write it like this: the probability that at least one catch the bus. All right, fantastic. Now, at least one means one of them catches the bus or both catches the bus. Okay, so either one or more. So let's have a go. If we want to find one person catching the bus, so far it's going to be a probability that Bob catches the bus. So Bob, and then not, so I probably should put his name, Bob, and not Bill. Or Bill and not Bob, or both of them catches the bus. So let's think about that really carefully, what I've just said there, because that is very, very important that you get that really well. At least one means only one catch the bus or both of them catching the bus. So this is my probability that only one catches the bus. Bob catches it, not Bill, or Bill catches it and not Bob. And then last of all, or both of them catching the bus. All right, cool. Let's now work this out. So Bob catches the bus, but not Bill. I've already calculated that here. So that's 0.27. I don't need to do that anymore. Or means I'm going to add Bill catches the bus but not Bob. I haven't done that one as yet, so let's get that one done. So Bob doesn't catch the bus, but Bill does catch the bus. So 0.1 times 0.7, so I'll need to work that out in a minute. Or last of all, they both catch the bus, and I've already calculated both of them catching the bus here, so 0.63. Now all I need to do is add up 0.27 plus 0.07, which is the middle here, and then add that to 0.63, which gives us a grand total of 0.97. So it's almost certain that at least one person is going to catch the bus. All right, so that's all for tree diagrams. You can use tree diagrams for various situations, so long as the events are independent of each other. You can draw a tree diagram and make this happen for you. All right, fantastic.